All right, let's start. Welcome everybody to our workshop on large models. My name is Achim Rabus. I'm a Slavist from Freiburg, Germany, and this is Dirk Alvermann from the University Archive in Greifswald. And we will be having a workshop on large models. As you can see, the workshop is not only on large models, it's also a large workshop. And thus, we have a very heterogeneous audience, ranging from almost absolute beginners to users who have already trained dozens of large models. This makes our task kind of tricky, but we will try to do our best to, accommodate. We just want to know who in the audience has never trained a Transkribos model ever. All right. Who has trained more than, say, 20 models? Okay. Well, thank you. We'll do our best. So regarding the languages you're interested in, predominantly, of course, the Western languages, Western European languages, and Latin script is really predominant. But there are also people in the room who are interested in Arabic, Hebrew, Cyrillic, Greek, and Devanagari. So we start introduction to the training tool. What do you need to train a model in Transkribos? You need to have ground truth, which is, as you all might know, digital high-quality images and the corresponding faithful diplomatic transcription. And then you might want to have a button in your Transkribos software that allows you to train the model. If you don't have that button, you might want to write an email to the Transkribos staff and ask them to unlock this feature. And then you use the ground truth to train the model. What do you need to do? You need to select the ground truth for training and validation, and then you need to define the number of training epochs. What's that? One epoch is you have the artificial intelligence and neural net having a look at the data, at the training data, and then trying to guess without having a look what is correct and what is not. And afterwards, the model looks again and finds out what's been wrong and improves the recognition process. And the more epochs you have, the better your model gets, right? And then you hit the start training button and you go get some coffee or go on holiday or whatever, because training large models takes time. If you have a small model with very few epochs, you will be able to have it trained in like half an hour. I trained 2 models during the morning session today. But if you have large models, it will take more than 24 hours. I suggest we just have a look at the training module in Transkribos right now.
I need a kind of definition of a ground truth.
Yes. Definition of ground truth. Ground truth is you have high-quality digital images and faithful transcription. And you have corrected your transcription, and it fits perfectly to the digital image. And then you define it. This is the data I want to use for training the models.
I think it's better said that you can have an exact transcription of the gaps.
Sure, but this is what we all have to deal with because we are dealing with mostly historical material.
Still be ground truth.
Sure, yeah, you will have to define it as ground truth. I think Dirk will talk about that later on.
Yeah.
All right, this is Transkribos, and you have to click the Tools button, and then here you see the Train button. And if you don't see it, you'll have to write an email to the Transkribos to enable this button. You click this button, and then you see your data on the left side of this window. You take this data and you click on Training. You can use a whole folder for training. It's gone there. And then you have to select some pages for validation. Validation data can be from the same manuscript or the same data, or can be especially selected, especially selected pages. You can, for instance, do it like that. And then you have to name the model. You have to choose a language. And then you can define a number of training epochs like here. Experienced users may have encountered that the default value has changed in the last couple of weeks. We used to have 200 epochs as the default value, and now it's been reduced to 50. Actually, I don't know the reason why, but from a user's perspective, 50 epochs might be enough for a small model, but if you want to train a large model, you might want to increase the number of epochs. 200 might be okay for a normal model. A large model will have 500s or even more than that. So let's move on. You click OK. We won't do that now, but that's the way you might have to do it. So what happens now? On the server here in Innsbruck, the model gets trained, and if you have selected everything carefully, you will end up with a very beautiful fitted model on the left side, which means that the CER, which stands for character error rate, and the lower the CER, the better your model is, right? And if your training CER and your validation CER are more or less the same, you have managed to train a very well-fitted model. However, if there is a great difference between training CER and validation CER, you have overfitted your model. Overfitting the model means you the neural net adapted itself very well to your training data, which is the data the model has seen all the time, but copes not very well with your test or validation data, which is the data you want it to work on. And if you have an overfitted model, that's not good. What do you do if you have an overfitted model? You add more ground truth for training, or you select your validation data more carefully. So, what can you do with the training parameters? As a rule of thumb, around 10% of ground truth should be reserved as test or validation data. If you have a very large model, you can use less. But if you have a very diverse data, you might want to use even more. And Dirk is the expert on that, and he will talk about that in a minute. Regarding the epochs, as I've told you before, you can start with around 50 epochs, but you should increase the number of epochs as soon as you have more data. Regarding a couple of publicly available models, we can have a look at the relationship of test of train and validation data, and you see they are in the range of around 2.5% to 5%, which means these are quite large models. If you have large models, it seems to be kind of best practice not to use too much validation data. Maybe there's a threshold that indicates the validation data is enough. I don't know, maybe 10,000 tokens, 20,000 tokens. We can talk about that later. With regard to training epochs, you see this green line in your images, and this green line indicates the point where the model has been trained enough, simply speaking. And you see 400 has been a bit too much for this specific model. 340 would have been enough. Regarding the significance and the impact of increasing training epochs, you can have a look at these images. this is one and the same training and validation data, trained on the left, trained with 400 epochs, and on the right with 1,000 epochs. And you see you gain around 0.2%. It gets better for like 0.2%, which might be worth the effort when dealing with a very large model. But if you have a small model, just don't bother. What means large? This is a question. So we have a couple of publicly available models here and a couple of models, one model that is not publicly available yet. And you see most of these models have more than 300,000 tokens in the training set. Some models have few different writers, and one has extremely many writers, 800. Some of the models have special skills. We will talk about that later, what that means. And the CER varies from 2.5% to almost 9%. And the special skills and the number of writers indicates that there's a difference between large models and generic models. Not every large model is a generic model. So, as a rule of thumb, we can say that most large models have more than 200,000 tokens. And if you integrate several writers and maybe integrate several languages or several script styles, you might be able to produce a generic model. And this is more or less our definition of a generic model. And Dirk will talk about what large and generic models should do in theory and practice.
Okay, now time for examples. What large models or generic models should do. This could be a normal use case for a generic model. As you can see, you have different writers, two different writers on one page. It's not much. You have German current in this area. You have latent cursive writing Latin language. It's normal for German scriptures in the 16th, 17th, 18th century. The writer will change scripture with language. So you have two languages, German and Latin language. More, you have concept writing in the marginalia. It happens often if you down select your material so well that you produce only or that you process only nice written pages. And then you will have abbreviations all over. One here, another one, the next one, and so if you want your model to read different writers, different scriptures, different languages, and abbreviations, you simply have to train it to do so. That means your ground truth has to have all these examples in it, and a model can do it. Let's start with different languages. That's an example where you can see very well the difference between the scriptures, Latin and German current. The ground truth, not so strong model, trained on this material, made not much mistakes, but there's a difference between Latin and German language, and a very good fitted model, Model 3.1, has the same CER on Latin and German language, more or less. Ground truth, not well-fitted model, and very well-fitted model. And the green one is the German current reading result. The red one is violet one as the Latin language. So you can achieve the same CER, one model, same CER, both languages. Abbreviations. I don't know if somebody of you were on the last Transcribers user conference. There was Guntram Leifert who declared that the HDR Plus is able to read more or less 2 to 3 characters in abbreviations, but it does it very well at the beginning and the end of words. So word at the beginning and abbreviations at the beginning and the end of the words. Here you can see typical abbreviations that occur on every page. This in videtur, the UR, studiosus, US. neque, atque, denique, semper. Datum with the titulus over the U, and typical German ER for der Teufel, the devil. This works very well with an HTR model trained on these abbreviations. It will get more or less 80% of these abbreviations in your HTR result. What, in my opinion, doesn't work very well are inward abbreviations, complex abbreviations like this one. Everyone who works with Latin text knows this, propter. That's difficult for the HTR. In puncto, it's a contraction. Contractions are not read very well with HTR. Omnia, the same thing, or domino. In my experience, these abbreviations, it's not worth to train them. They occur not very often in the text. If they are there very often, you could try to put them into the ground truth and to train them as well. Maybe you will have success. I know that Achim trained models with inward abbreviations that are read very good. My opinion is another one. Next one, concept writings. This is very tricky. A generic model could read concept writings if it is trained with enough ground truth on this material. If you remember the morning session, we talked about Ottoman Turkish and the problem that not every character fits or matches to a single other character in the transcript. It's similar with concept writings. Concept writing means that we have words like this one. It's called mit, M-I-T-H. You won't read these characters in the original. But the system could try, it could be trained to read it. In this case, it didn't work. It read a totally different thing. The second line, the line which is marked, would be in ground truth, peinlicher Frage zu, here is written, erkundige. The transcriber was not as good as the model. The model read Frage, that's right, and here it read zu erkundige. What's written in the concept is zu Erkundunge. So the model was better than the transcriber, but the model wasn't right. In my experience, you can train concept writings, but have in mind that you won't reach a better rate than something like 10, 12, 15% CER on concept writings up to now. What could help is language models or dictionaries, but this we will talk later on this topic.
Can you say a word on what concept writing means? I never think that.
Concept writing means, in some cases, like in this marginalia, the writer has not much space and he tries to write very fast and very economic. So some characters,
More keywords.
it's more keywords. Some characters won't be written in the word, and it's a kind of you as a transcriber has to make an interpretation of this what you see. Normally, HDR shouldn't interpret the text; it should read it. So you have to train it to interpret. It's not its task normally.
It's important to keep in mind the limits of generic models. There are some weird things going on when using generic models for transcribing previously unseen data. For instance, it might well be possible that hypercorrect forms, hypercorrect transcriptions occur. What does that mean, hypercorrect forms? For instance, if you have German from a specific time, they write mit, M-I-T-H. Not in concept writing, but in usual writing. And the model, the generic model, learns this feature, kind of learns this word. And then you have another source, and in that source, mit is written M-I-T, right, without the H. But nevertheless, it might well be the case that the model transcribes it as M-I-T-H, even though there's no visual cue whatsoever of this H. This is because the model learned that this word has to be written that way. That can very well occur if you use generic models. That's one drawback. Another drawback is that you most likely introduce more noise than using specific models. This is usually due to different transcribers and different origins of the ground truth and things like that, which means that you might be sometimes you might be better off using a specialized model. In my experience, the following rule of thumb applies. Generic models are great for non-computer savvy users who want to benefit from transcribers efficiently and fast. So if you're not into digital humanities, if you're not into computers, or you are obviously because you're here, but if your colleagues are not, and they want to benefit as well, it might be easier for them to use just one generic model than to have like 20 different models for different purposes. So another limit is, of course, models are usually language specific. If you train a model a specific type of Roman script, it will learn the linguistic features of the particular language. And if you try to use this model for another language, it will perform very poorly, even though the paleographic characteristics of the script written in this other language are quite similar. But this is just a property of the typical neural network we trained in transcribers. But if you want to use a generic model for different languages, you can train it multilingually. That's no problem.
Okay, so this is something that I don't want to do because it's hard. How to organize text, test, and training material. Many of you have asked about the best way to organize material for training and validation. So to be honest, there are lots and lots of individual ideas on how to organize material. With generic models, in my opinion, and it's the only thing I can talk about, the greatest challenge is to create really well-balanced train and test sets. I think there are two options that I want to present you, one conventional and a less conventional. I prefer to separate the material in different folders, so to separate training material and validation material before starting anything. Then I prefer to establish an order. This depends a little bit on the material. So I did chronological orders for models that should cover, for example, a century. And I did an individual order for writers for models that cover a long time period, but with not more than maybe 20, 30, 40 writers. It makes sense in this case to establish an order for writers. The next thing, that's not enough. The next thing is to form corresponding groups of test material and training material. It makes no sense to train a model for the period of 1500 to 1510 and to get a validation set from 1560 to 1570. So the sets must be corresponding in their order. An example, chronological corresponding groups. Achim has shown the training tool, and you were right. Before adding, my second advice is use the versions management. Don't do things like use the edit status. If you do transcriptions, ground truths or other things, set the edit status of a ground truth page to ground truth. And before you start training, before you select the train set or the test set, take the filter, ground truth only. That will make sure that only really pure material, 100% right transcriptions will be at the end in the train set and in the test set. So the versions management is exactly made for this, so use it. It will make life easier with large models. In this case, I added complete training documents. My training documents are the complete documents, and within these documents you will find pages in edit status, ground truths, and other pages not transcripted, and so on. My test sets are corresponding to the same years, and I add them in the run of the training for the same years with the trained material. So we have material from 1582 up to 1588, and these are corresponding sets of training and test material. You can group them in the same way for individual writers. It's more or less the same procedure. Okay, the question that has to come at this point is how to choose single pages for training and test sets. That's not so easy. In this case, I'm sure there are a lot of other individual ideas. If possible, you should choose representative pages. That means select pages of transcribers, neighboring pages of the same transcribers. In my group, we select more or less 2 or 3 pages of one writer and made ground truths of it. 1 page of every third writer comes to the test set and will be set it up to edit status final so that I can recognize it that it's not ground truth for the training set. Afterwards, I export all the final pages of such a document and re-import them to transcribers and to form from them a new document, which is a test document that includes only test pages. So, to make it more clear, this is an overview of one of my documents. I don't know which year, 1627. The transcribers make their proposals for me, and the blue ones are ground truths. You can see neighboring pages, same writers. In this case, we selected 1, 2, 3, 4, 5 writers, 6 writers maybe. The red ones are the final pages. They will go to the test set. The blue ones will go to the training set. And that's all what we do in advance for the training. This is the conventional way to select pages. It's a little bit complicated, isn't it? As always, there's an easy solution, an easy way too, and the easy way is sampling. Maybe you heard what Sebastian told this morning on compare samples, the compare samples tool. It does exist just for a long time, but it's worth to be recognized as what it is. It's genius. You can sample, in first stage, I think, test material. Samples have many advantages. They don't consist of whole pages. This is one advantage, but only of single lines. That means you don't have to transcribe so much for your test set. And they are automatically generated and randomly selected. This is a question that some of you asked in advance of this workshop. How could I get a randomly selected test set or train set? You can do it with samples. To do so, there are different ways to create samples and sample sets. You can do it in transcribers, so you have only to start the sample compare and can add from your collection single documents or single pages to a sample set. Then you can choose the number of lines that you want to get out of this. So here I added, I don't know what, a couple of documents, more than 1,000, and I told the system to give me 300 lines back. What you have to do first is a layout analysis, otherwise it wouldn't work. This is one way. So you will have a sample set with 300 lines to transcribe and to use as a test set, for example. You can do it, and this is my advice, outside transcribers, off platform. Probably before importing all your material to transcribers, you will have it in a file system. I think so. Most of you have. Simply take in your data management system, in your file system, select every hundredth image, and then put it to a single folder import this folder into transcribers, and so you can get more or less something like a very extremely varied sample of all your material, what goes not to the training, and from this document you can let transcribers select, I don't know what, 1,500 lines to create a line sample of all your writers in the material, and it will be randomly selected. So you can't cheat, and the system can't cheat too. This is what it looks like at the end. What you get out is, in both cases, is a document that consists only in lines, pages, but the page has only one line. So what you have to do is to transcribe 500 lines, and you will have a very representative test set for your material. Yeah, everybody should have one. Each line represents then a page or a writer, and the effort of transcription, this is a simple calculation, is less than with conventional test sets. I think, instead of transcribing 20, 30 lines per page, you have to transcribe simply one line, and that's all.
All right, let's talk about the byproducts. Sebastian talked about that in the morning session as well. If you train a model, you will get both dictionaries and language models. And the dictionaries are not very good, whereas the language models are. So dictionaries are essentially a list of tokens that are found in the training data, either with or without the added frequency information. And dictionaries follow the so-called rule-based approach, which isn't artificial intelligence. And since HDR is AI, this means that HDR and dictionaries don't fit together very well. However, as Sebastian told us in the morning, language models are also instances of AI, and they are created from the ground truth during a training session. And I will cite Goldberg for a definition of language models. Language modeling is the task of assigning a probability to sentences in a language. Besides assigning a probability to each sequence of words, the language model also assigns a probability for the likelihood of a given word or a sequence of words to follow a sequence of words. There's an S missing. All right. So the language model is able to make an informed guess for the following word. And because of that, HDR and language models fit together quite well. In our experience, you can reduce CER by using language models by around 1 or 2%. As a rule of thumb, don't use dictionaries, use language models. If you have a very bad model, dictionaries might help. But if you have a decent model, you can boost it by using the language models.
Okay, maybe it's necessary to say that there are experiences with dictionaries and single writer models and very specific models where dictionaries could help, because this writer should have a specific range of words and a specific topic to write on. In large models, dictionaries won't help. So I give you some specific examples, dictionaries and large models. This is one of my annual test set for 1 year, 24 pages. The blue columns are the pure model without dictionary. The red columns is the HDR result for the model with dictionaries. The arrows indicate on which page the CR has become worse after using the dictionary. So you can see in more than the half pages the character error rate was worse than without dictionary. You will hardly notice this effect when looking only at the average CR of the model. For example, simple compare or advanced compare with the average CR. You will notice this effect, especially if you go in the document and make a kind of advanced compare for single pages to see what happens really. This requires a detailed validation before you decide to apply a dictionary for a whole couple of pages, like 100, 200 pages. In my experience, dictionaries are not worth to be processed with large models. Language models, totally different. Well, we had not so much time to test language models. They came with the last version of transcribers or with the last snapshot. With language models, it's different. This is the same model. In this graph, you see the test sets grouped by years. So for a couple of years, I started the validation with my model with and without language model. The blue one is without language model. The red one is with language model. You can see language models almost always lead to an improvement of the CER for the year where they were applied. I have applied them to this chronological series of test sets to see if there are peaks in one or other direction, but I was surprised that the language model works in all the years. In every single years, the performance with language model was better than before. So this could be a way with generic models, apply the language model and see what comes out then. My experience, 0.5%, 1% with trained material, and maybe with untrained material, with absolutely unknown material, you can get 2 to 3% better CER with the language model. Another one, they have similar effects. They are not perfect. They have similar effects as dictionaries. It depends on the quality of your model. Here you have 2 different years, 1604 and 1655. In this time space at the beginning of the century, my model is very strong and it makes no mistakes, or it makes mistakes but not so much. In the higher time level, 1655, the model makes more mistakes. In a very fitted area of the model, there are pages where the language model did mistakes that weren't there before. In the not so good trained area, the language model is almost better than the pure model.
I would like to tell you something about the so-called recycling approach, which in my opinion is an efficient way to get from zero to something. Imagine your community is not very large. I'm a Slavist by training. I'm interested in, among others, Church Slavonic. And I guess there are not very many people in this room also interested in Church Slavonic, which is a pity. But as a matter of fact, there hasn't been done much yet with respect to training models for Church Slavonic. And what do you do if you do not have many resources to produce large amounts of ground truth manually? I suggest you just browse the internet, look for already available digital editions, and recycle this data, download the images and copy-paste the transcription into transcribers and use it for model training. You might also want to ask your colleagues if they would like to send you Word files and digital images of traditional editions. This is what happens in my field all the time. People are more or less conservative. They use computers as a better kind of typewriter, so they have their manuscripts. They use a computer to input the text into a Word file, and then I print a book and throw the Word file away. But I suggest we recycle these files originally intended for printed editions. We recycle these files for producing ground truth in an efficient way. Yes?
There is no problem with copyright?
Well, you'll have to ask. If there's an internet edition, there's a license and you can read the license, and if it's open source, there's no problem at all. And if you talk to the colleagues, they should know everything about intellectual property rights.
So basically we have to request.
Well, With respect to the recycling, you have a question too?
Yeah, I'll keep it for later.
All right. With respect to the recycling approach, you might need to conduct some pre-processing steps. In my field, there are a lot of, pre-Unicode encodings. It used to be very difficult to reproduce Church Slavonic letters. I think if you're from Greek studies or Devanagari or things like that, or Arabic, you know this issue very well. And you might need to add some pre-processing steps. But in my opinion, this is a very efficient way to get from 0 to something, and you might be able to greatly reduce the costs and help your community by training models and make them publicly available.
Just to respond to the question of the copyright, as long as you don't put the data open, you can create a model, but without the training data underlying it, then there's no copyright issue.
Yeah, sounds reasonable. Yeah, good, thanks.
So I'm wondering, because in cases like this, what we're thinking about is, let's say, a classical edition, and then one question is whether it doesn't create a problem of overfit, of not hypercorrection. So you get the traditional edition, and then it would be sort of trained to read the classical rather than the actual version that you're trying to transcribe. This is just a question.
All right. So you're talking about normalization and emendations and things like that. You see, in my field in Slavic studies, we used to produce very faithful editions. Letter by letter. And so I can use it. But if you have a normalizing edition, the model will learn how to normalize, if you like it or not.
And the other question is actually, if you, I'm all for using this, and especially when you have, editions of the Bible or other classical works, wouldn't it be better to use the smaller segments of, let's say, each chapter or even per page language model or even dictionary to use as in order to also minimize the effort? You see, so instead of, or actually in T2I you basically do it because you give it the text.
Yeah, well, I think generally the more the better. If you have more pages that you can copy and paste, the model will get better. If you have a very limited amount of time, you might want to select randomly, of course. Yeah, that's true. All right, we've talked about that before. If you follow the recycling approach, it might well be the case that you introduce even more noise. And you'll have to think about if you can live with that noise or not. And maybe you actually can live with it. You will lose like 1 or 1.5% of CER, but you will be able to train your model considerably faster than when getting rid of the noise beforehand. Yeah, it's always a trade-off, but I would like to suggest that you think about that.
Working with base models, only a few of you have asked on base models. I think because base models, the possibility to train with base models in HDR Plus exists since November, September, something last year. For the colleagues that trained models with simple HTR 2 years ago, they know very well how base models work. So this is a kind of refresher and to show you what base models can do with HDR Plus. As we heard this morning, base models are thought by the developers like a kind of help to getting started. In my opinion, there are at least 2 other strategic ways to use base models with some problems in it, but I want to present you these 3 strategic ways. As a starter model for the further development of a model, or even for combining writers. Some of you asked how to combine writers from specialized models into a kind of generic models, and then last point, as a kind of model booster for large models. First one, You can use base models as starter models, but this is not really necessary. I think Dorothee Huff, she trained 2 series of models for me, or I asked her to do so, with a base model and 1,500 words, 10 pages on the base model, ground truth to the base model. And there was a difference between training with base model and without base model. With more than 40, 45 pages, you won't need a base model to get started. This is enough to have an own solid model that will work good on a single writer. With generic models, it's a little bit different. But the real power of base models is to find in a different area. Base models, as we heard this morning, remember what they have learned up to a certain point. So every new training you will do with the base model, with your last model, improves your model. Base models are useful for continuous development of a model. If you make a series of 10, 15, 20 training sessions to get one good general model, base model is the way of choice. I'm not sure at the moment, because Sebastian told this morning that the base model it's not sure that the ground truths of the base model will be remembered for all the other training sessions in the series. My experience up to now is it does remember. And first I give you an idea how to start a training with base models for all those who never did. You simply activate the filter because you use the versions management. We did clear that you have to use the versions management, ground truth only. Then you choose the base model. In this case, I choose the base model from another project. This is quite good. Then you add only the new ground truth, not the whole, 1,000 pages of the base model, only the new ground truth. And then you use the old validation set of the 5.1 model. This is what you can get in the HTR model data. The validation set will be there to find, and you can add it simply from there to the validation set. And then you can start the training. What I did in this use case was a base model with 150,000 words and 8 different writers. It was trained with 500 epochs up to a CR of around 4%. In the new training, I added only 10,000 words, and I added only ground truths for 2 of the 8 writers. And I retrained it with 500 epochs to make it comparable with my old model. And the CR of the new model is 3.8%. This is not so much as I expected, but if you do specified validation, in this case, these are the 2 writers for whom I added ground truth, Balthasar and Engelbrecht. The blue columns are the base model, the old model. You can see that for all the writers, not only for the 2 writers where I added my ground truth, the results are better than before, thanks to 500 epochs more training on a base model. So I repeated the training, and within the training, the model remembers what it had just learned, and so this is a better result for all the writers. With combining writers, try it. Maybe you can get this way a really combined model for more writers. Model booster. If you want, you can improve strong generic models with the help of public models that are available in the transcribers community. So, for example, this is a technique I tried with only very large models. Using a large model as a base model, you can improve your model. 2 advices before starting: check the properties of the base model. Don't use a base model that doesn't fit to your material. If possible, try to predict the performance of the base model on your material. I will show you 2 ways to do this. This use case is on material from the 17th century. In the public models, there are two models available that could suit for my experiment, the German Current M1 Plus from the transcribers team in Innsbruck, and the German Current model of Tobias Hodel. The first one has 1 million words ground truth, the second one 1.5 million words ground truth. They both cover the 17th century, where my material is situated, and both are trained for German Current. So I tried to make a prediction first. I used the sample compare. I have a sample set with my untrained material, and I started a sample compare for both models. As you can see, the winner is German Current from Tobias Hodel, German Current M1 Plus, 24% of my material. So I choose the second model as a base model for my training. I added then 108,000 words. My model has a CER of 7.3%, average CER. Then I retrained my ground truth on the base model German Current and reached a CER of 6.6%. So this is nearly 1% better without adding any new ground truth. No page. So, and if you follow the line for the single years, which is covered by the model, you will see that it's not a statistic anomaly. It's in all the years, the resulting model was better than the base model and better than my own model without doing anything. This is what base model training, model booster means. Try to do it if you have a strong a strong model of your own and a strong base model, and if they fit, try to get more out. Okay, this is on base model training. At the end, validation. I have spread something on validation all over the presentation, so I will do simply an overview on the validation tools. You have 3 validation tools, compare text versions. You can find them in the Tools tab. Compare text versions, compare, and sample compare. Okay, compare text version is a nice thing. If you love numbers, you will, all we are talking about a CER of 5%, 6%, but to get an impression how the model performs, it's very helpful to see the text versions and where the model works and where, in which cases, it don't work very well. This is a word error rate of 12%, as you see, and the compare text versions gives you an idea how to deal with character error rates. So the character error rate is a calculation using the total number and then all the insertions, substitutions, and deletions required to arrive from the HDR result to the ground truth. This means every wrong character, doesn't matter what kind of character, is an error. But if you look here, not all these errors have an effect on the search impact of your model. It depends on what you want to get out at the end. If you want a searchable text, plain text, half of all these errors calculated in a character error rate are not important for full text search. So don't worry about the CR. Check it in some kind of overview. I think you know all the other possibilities to make validations. It's the simple compare only for single pages, a free choice of reference pages. You can compare whatever you want with each other. It doesn't have to be ground truth. This is the same page that you have seen before. In the compare tab, you have a very useful validation tool, the advanced compare. Advanced compare makes sense if you group test sets for years or for writers. You can start a validation for a whole set or for a whole document, and you will get the single values for every single page. So the CR for this page is something like 7%, and you can see that there are a lot of pages in this group under 5% CR, and then there are some pages with not normal peaks, and this is a way to go and look at these single pages and see what happens there. Is it a single writer? Is it a special kind of scripture, maybe concept writing, Latin writing, whatever, and to analyze where you have to work better with your ground truth or something else. This is how it looks like, a little bit larger.
Can I ask something? Do you have any insights about how to interpret the relations between the word error rate and the changing relations? For example, in page, I think, is it 9?
Yeah.
No, in 18, where you have a larger, well, you know.
The word error rate is larger in every case, larger than the character error rate. That's clear.
Yeah,
that's for sure.
The relation is 1 to 10, and sometimes it's 1 to 2. So.
Yeah. I would have to look at this page to make it clear. This kind of validation helps you to get into the material, to analyze what went wrong, and then to do so. Normally, I don't appreciate the word error rate. I never work with it. It's not important for me because it doesn't indicate nothing. It shows you, it assures you that even with a CER of 2%, if your word error rate is 5, 6, 8%, that means that every 10th word won't not be found in a plain text search, nothing else.
But it can be that it's capitalized and it shouldn't, or that there is a comma that shouldn't be there. And
it shouldn't be there, but it doesn't matter for the search. Yeah.
Just want to know that if you click on the result of one page in the advanced compare, you also see the text compare versions. So you can look at the texts in there. So if you have page 8, for example, where the character error rate and the word error rate are kind of far apart, so in this upper table, you can double click and you can see the text versions of it, each page. So you can compare it inside there.
Yeah, the versions of your, that's right. Okay, sample compare, predictions. So in the workshop title was written how to make predictions with models. This is what you can do with a sample compare. If you create a sample set in one of the ways I presented you are able to make predictions on the impact or the performance of a model on your material, or maybe of a model that you haven't trained yourself. I showed you this with the German current M1 and the other German current model to make a prediction how it would work on my material. Another thing is to make predictions, for example, for the works with dictionaries or without dictionaries. If you have a sample set, you can simply run the HDR with language model or the HDR with dictionary on your sample set and then compare the validation or the predictions of both. In this case, I run my model, a strong model without language model. So the prediction is 8.5% on the unknown material. And then I run my model with language model, and the mean is 6%, so 2.5% better than without language model on unknown material. That's, for example, something where sample compare can be used very well to make predictions for your own material.
All right, that's basically it. Thank you very much for your attention. Thank you.